All right, good morning, good afternoon, and welcome, whatever it may be. Here is to supplement on our lesson in class, Lesson 2-1, Angles and Congruence. Uh, Angles we've worked with in previous math classes, mostly 8th grade. So a lot of the information that we're going to cover is things that you picked up in middle school or just from experience. But we'll go over them. And then, of course, congruence. Congruence is something that we've already talked about, meaning things are equal, are the same. So with that, the goals that we're going to talk about, we're going to analyze using definitions of angles and parts of angles. We're going to calculate angle measurements using our definitions of congruence and bisectors. So again, those two words we've already gone over. We're just going to apply them with angles and analyze figures with these characteristics. More vocabulary, adjacent angles, linear pairs, and then vertical angles. These are definitions that we're going to carry throughout this course. So once we learn them, it's just a matter of practice and then working with them. So it talked about parts of angles. An angle is consisted of two rays that end at an angle is a pair of rays that have the common endpoint. So this is what we typically see as an angle. I have this angle measurement right here. This would be considered my vertex. And if you look at it independently, you have a ray here that goes from A to D, and it goes on forever, and then a ray that goes on from A through B and C that goes on forever, A being my common vertex. But that's the angle. So thinking about the parts, understanding what a ray is. Thinking about we have a line, or if we wanted to consider this, hey, we got this line going on forever, ever in both directions. Well, a ray has a starting point, or called its end point. So in this case, looking at this notation, ray AB. Well, what's that saying is my ray starts here at A, and then it follows this line and passes through point B. Okay, so that would be ray AB. Or since it does continue on, right, it continues on through this point right here. They're collinear, so it doesn't matter. We could call that same item either ray AB or ray AC. It is the same thing, just annotated differently, but it does identify the same location. Two collinear rays, this is important. We have opposite rays. Opposite rays form a straight angle or a straight line as we think of it. So two collinear rays with a common endpoint are opposite rays. Opposite rays form a straight angle, and a straight angle is 180 degrees. So we have this image right here. We have overlapping rays, tons of rays that we could think of. But if I just simply said that I have ray AD, and you'll notice the direction of my arrow still goes the same way no matter what. My endpoint is A, and it passes through D. So here's my endpoint, and I go this direction. And then I also have ray AB. And here's my endpoint, and it passes through there. Those two opposite rays form a straight angle, and that is right here, 180 degrees. So a straight line is 180 degrees. So there we go, and those are how we form angles. How do we label angles? Multiple ways, but right here, the naming conventions, well, we can simply call it by this angle we have right here. We can name it just by its vertex, because that is the only vertex for that point. So we could say angle A. We could also call it angle DAB. We could call it angle BAD. We could also call it angle CAD. Just thinking about this, though, noticing that my vertex is always, I either call it by a vertex or DAB, DAC, CAD, or BAD. So when I'm using three letters to name an angle, my vertex always appears in the center. So that is something that you can identify from its name, the vertex. The rays are the sides of my angle, and then you have the vertex as that common point that they come to. So again, I have ray AD, I have ray AB, they have a common vertex of A, and there is my characteristics and parts of an angle. Hopefully this is a review. These are some basics that go back to our elementary school. You know, when we talked about geometry, angles, measurements, those kind of things. Okay, more characteristics. So you have an angle divides a plane into three distinct parts. You have the angle measurement, or you have the angle. That's the items that fall directly on your rays, right? Your rays to your vertex, that is my angle measurement. You have what would be the interior. The interior of an angle is the, hopefully you can see this, that it's in between my two rays, the close way. And then of course, the exterior of my angle is what is outside my angle measurement. Let's see, looking at this, using a figure to identify angles and parts of angles, there is a lot of information here as we see this overlapping stuff. Things to be able to identify. This 2 in this region, for example, would be calling this area right here angle 2. So if I were to shade that in, this area right here would be considered angle 2. That's what they mean when they say angle 2. It would be all of that right there. That would be the interior space of angle 2. The exterior space would be out here because that is not included inside. Now, so that's one way to label our angles. Another way could be, in this case, let's see, angle C? Can't do that one. I'm trying to think here. If we look, for example, I can't just say angle C because this point could be this angle, could be this angle, could be this angle, could be this angle. So you got to make sure that when you're labeling it, we can't just say angle C. But looking at those characteristics, let's answer some questions here. Name all the angles that have D as a vertex. All right, here is D. Right here, D. And what are the angles that have the vertex? And they've already given us some of the things. I'm going to go ahead and label them real quick. Okay, looking at that, I wanted to quickly do that. Let's see here. We have EDF. We have EDG. We have FDC. We have GDC. We have CDH. We have EDH. And then we have FDH. There are a few more. Gosh, you could say no, I don't want to do that one. You could say BDE. Okay. Now we didn't repeat that. That's a repetitious one where we have FDE and BDE are actually the same angle. Also, angle 7 is the same angle. So those kind of things, you have to keep that in mind. There's multiple ways to label an angle. Just need to be cautious. Name the sides of angle 2. Here, looking at angle 2, here is angle 2. So my sides, I have two rays that I can use, and I'm just going to say I have BA, and I also have BD, would be the sides of angle 2. Name a point that is interior to FDE. All right, so FDE is this way. Right, there's my FDE angle. Those are my interior areas. So the only interior point that I can label there is going to be point A, because the other points are actually on it. And the name of point or points in the exterior of FDE. Well, let's see. Exterior, I could pick C, H, or G. Those would be considered exterior. So C, H, or G would all be exterior points. So just being able to understand the parts, the characteristics, using our definitions. Okay, so looking here, use the figure to identify angles or parts of angles that satisfy the given condition which angle has sides DB, okay, there's one side, and DC, Okay, so I am looking for points or letters B, D, and C. B, D, and C. E is not included. A is not included in my naming, so those aren't included in the sides of DB and DC. I can look here and say angle 2 could also represent that. So that is an answer. And let's see here, angle 3. Angle 3 is over here, so that can't represent that. And then I have BDC. BDC, okay, that is a possibility. And then I have CDB. Both of those are possible. So there's 3 different ways that we could have named an angle with sides DB and DC. All right, so that is understanding those parts and definitions. Congruent angles, ladies and gentlemen, congruent means the same. So when we have congruent angles, our congruent angles are the same. They are indicated in this figure using matching arcs. So in this case, angle QTR has an arc and angle STR has an arc. So we know that those 2 angle measurements are the same. So if I said that angle QTR was 70 degrees, then even not drawn to scale, I know that this angle is also 70 degrees because those arcs mean they're the same. So that is what congruence gets us. A ray or a segment that divides an angle into 2 congruent parts is called an angle bisector. So looking here in this example, TR is a ray or a segment that divides QTS into 2 equal parts. So therefore, this is my bisector. Just like before when we had segment bisectors, we now have angle bisectors. So I know then that the measurement of QTR is going to be the same as the measurement of STR. And then I did this over here to know that, again, that betweenness, QTR plus STR is equal to QTS. I know that QTR is congruent to STR. I know that 2 times QTR is equal to the entire thing, since they're the same. And I also know that QTR is 1/2, this is 1/2 of the entire angle. So all of these definitions I know just by understanding angle bisector. So moving on. Here in this example, congruent angles and angle bisectors, let's see. It says in the figure, they're always going to define this stuff for you. BA and BC are opposite rays, and then BD bisects ABE. So that tells me that this piece is equal to this piece because it bisects. ABE, let's see here. If ABD is 4x plus 14 degrees, and DBE is 8x minus 32 degrees, I know that those 2 things are equal. Okay, it says find DBE. Well, if I know they're equal, I don't know what x equals, but I do know that those 2 angles are equal. The angles should have the same measurement. So if the measurement of ABD is equal to DBE, we substitute the values that they gave us. Then we turn around and did our inverse operations. We subtracted 4x from both sides to get our variables together. Then 14 minus 4x minus 14 equals 4x minus 32. We added 32 to both sides, again, to isolate our variable. 46 is equal to 4x, dividing both sides by 4. And I think we end up with 11.5. X equals 11.5. Now, once you find that, it asks for the measurement. It didn't ask for x. So if I turn around and plug into measurement DEE for x, 11.5. Let's see here. This would be, what is that? 88, 92. 92 minus 32 is 60, so DBE is 60 degrees. And hopefully that's what we're able to calculate. And thinking about that, so then I know that if this is 60 degrees, this is 60 degrees because they're the same. Remember, just thinking about what I said, that this opposite rays we learned a few pages ago that make a straight angle. So if that is a straight angle, then I know that these three angles together should add up to that 180. 60, 60, some number equals 180. So this angle actually turns out to be 62. So once we start learning these definitions, it starts giving us a lot of information. Okay, so in our check, in the figure, again, it wants to tell us that KJ and KM are opposite rays, so we know that makes 180 degrees. We know that KN is a bisector of JKL, so this is the same as this. So if JKN here is 8x minus 13 degrees, and NKL is 6x plus 11 degrees, we want to find JKN, and we can do that. So hopefully you remember that, again, if things bisect, it means they're equal. So again, I know that angle JKN is congruent or equal to the measurement of JKN is equal to the measurement of LKN. So you just make those two things equal. 8x minus 13 is equal to 6x plus 11. Do your inverse operation. Make them equal to each other, process your equation, combining like terms, subtract 6x from both sides. I have 2x minus 13 equals 11. Go ahead and add 13 to both sides. I have 2x equals 14. Got a little ahead of myself. 2x equals 24. Divide both sides by 2, and then x is equal to 12. So now if I know the value of x, it asks me to find JKN. Well, JKN I know is equal to 8 times 12 minus 13, and that equals some angle measurement. So we should have 96 minus 13, and that should equal to, let's say, 83. Right, 8 times 12 is 96. 96 minus 13 should be 83. 83 degrees. 83 degrees. 83 degrees. There we go. And you could even figure out what that missing value is just by knowing that all three angles add up to 180 degrees. Okay, more definitions. Special angle pairs. Understanding, here we go. Adjacent means next to. Some of the things that we learn about adjacent angles. Adjacent angles share a ray, they share a vertex. They have a common vertex and a common side, adjacent being next to. So angle 1 is adjacent to angle 2. This is a non-example because they do not share a side and they do not have a common vertex. Linear pair. Linear pair are two angles that make up a straight line. They are adjacent, they share a ray, they share a side, and they have a common vertex. So angle 1 plus angle 2 are a linear pair here. In this case, these do not form a linear pair because they do not form a straight line. That is not a straight line. So here, and I'll just remind you that the sum of an angle measurement of linear pairs is 180 degrees. Okay. And this is an example. We know that these are a linear pair because I have angle CBA, I have angle ABD. They have a common side, they have a common vertex, and when you add them together, they equal 180 degrees. So this would be another positive example of a linear pair. Vertical angles. Vertical angles are two non-adjacent angles formed by two intersecting lines, vertical angles are congruent. Okay, so here I have intersecting lines. Here is my vertex. And then the opposite sides, I call them opposite or vertical angles. 2 and 4 are opposite or vertical. Those two angles are congruent. 1 and 3 are congruent. And in this example, these are not two intersecting lines, so that's why these are not vertical. This does not make the same intersection. And I will just say that vertical angles are congruent, so 1 is congruent in this example, 1 is congruent to 3, so that's why it has 2 arcs. 2 is congruent to 4, that's why both of those have 1 arc. So just using that information and things that allow us to understand, just if you apply that vertical angles, if I were to look at this and put in some number, and I said that this is 40 degrees, then I know that its vertical angle is also 40 degrees. And things that we learn just a few inches above this diagram is that I know that angle 2 plus angle 3 equal a straight line. They form a linear pair, so I know that those two together equal 180 degrees. And if that's the case, I know that angle 3 is 40 degrees. So what in the heck is angle 2? All I have to do is combine like terms, get my numbers together, and angle 2 is going to be 140 degrees. So using our definitions allows us to fill in a lot of blanks. So just keeping that in mind, that's why we learn these definitions, because we will utilize them. Here in my word problem, vertical angles and angle pairs. The office lamp is made using two intersecting metal bars. Those metal bars are intended to be symbolized by lines. And then we know that a straight line would, I'm just thinking about it, a straight line would intersect, a straight line is 180 degrees. We know that opposite angles would be congruent, so I could automatically say, well, that's opposite. I know that these two angles are congruent. I know that 138 degrees and angle B would be a linear pair because they form a straight line. So there's a lot of things that we can come up with, but let's see here. How many pairs of adjacent angles do you see in the figure? List 2 pairs. There's several, but I'm just going to go with, how about angle ABE and angle EBC. That's an easy linear pair, so there's one pair. And then I guess I'll just throw this out here that I said that this angle and this angle form the linear pair. So I will just go ahead and say that this angle and this angle also form a linear pair. So I have angle ABD and angle DBC. Those are my linear pairs. You could have gotten a couple out of there, but that's what I got. Identify 2 pairs of vertical angles in the figure. Okay. Well, we just did, but I did it a second ago over here. But I know that let's see, clean this up a little bit, right? Looking for 2 pairs of vertical angles. I know that these 2 angles are vertical, and I know that these 2 angles are vertical. So if I take that, I could say that angle EBC is congruent or vertical to angle DBA. And I know that angle ABE is equal to or congruent to angle DBC because they are verticals. How many linear pairs do you see in this figure? 1, 2, 3. I actually see 4. We listed 2. But we also had 2 more that we could have looked at. This angle and this angle form a linear pair, and then these 2 over here form a linear pair. So that's one of those things that we could have identified. And then find the measurement of EBC. EBC is vertical to this angle, so EBC should be 138 degrees because we said, remember that. And then ABE, we know that right here, ABE and EBC are linear pairs, so we know that together they equal 180 degrees. So angle ABE plus 138 degrees is equal to 180 degrees because they form a linear pair. Simply subtract 138 from both sides, and angle ABE is equal to 42 degrees. So there you go. Just thinking about the different stuff that's presented to us in that problem. And let's see, I don't know a lot that's going on here, but before I even look at this, it appears to have two intersecting lines, which means that if I think about it, these are vertical. So that's 88. I know then that this should be 180 minus 88, which is 92 degrees. And then it is vertical to here, so this is 92 degrees. I haven't even looked at a question yet, but I'm able to figure those little bits out. So let's see what the question's going to ask me now. If the city planner is designing a park, he wants to place two pathways that intersect near the center of the park. If angle GED is 88 degrees, identify the true statements. Okay. DEF is 92 degrees. That's a true statement. DEG is 88 degrees now. FEH is 88 degrees. That's a true statement. DEH is a straight line, so that is not a true statement. And then GEH, we just said is 92, so that is also not a correct statement. So it looks like A and C are correct statements. So there you go. Just quickly, I was able to label some stuff before I even looked at the question that helped immensely. So just keep that in mind. Label what you have, understand your definitions. So with that, we will go ahead and work on our assignment.